All right, welcome everyone. Today we're going to be talking about validators and serializers in Django. During part one of our lecture, we're going to be talking about validators and tests. In this lecture, we're going to talk about the process for creating a model. We've already created models, but we haven't necessarily been implementing it the correct way up to this point. We're going to talk about what those validators are, how we can add a set validators, and then we'll actually go into writing some tests with Django test case inside of Django. So just like Cypress had end-to-end test suites, um, Django comes with its own built-in test suite that's available to us for being able to write um, unit test. We're not going to write end-to-end test with this. If you did want to write end-to-end tests with Django and you have something like a full stack application going on, I would recommend using Selenium. And if you're trying to write some sort of end-to-end test, or I guess there would be more integration test, when it comes to your API, I recommend that if you're not utilizing Django test case, to utilize something like Postman. But we'll go into all of those technologies later on. All right. Now, with that said, does anyone have any questions over what we'll be covering today? Perfect. If no one has any questions, let's talk a little bit about our project up to this point. We can see that I still have the same exact database from yesterday. That container shouldn't get taken down, and I don't recommend that you take that container down for the remainder of this module. So please leave that container standing. Currently, if I run Docker PS, you'll see that I have two active containers, one of them for Django and the other for my database. Here's my container running my database. And here's my container running my Django application. All right, we could change this so that it's running in the background just like our database is. But in this case, I actually want to see my server accepting request. So in case I need to debug, I can see an error populate inside of my terminal. All right, my project looks exactly the same as it did where we left off yesterday. If we open up the Pokemon app, we have our model that we talked about yesterday, designing our Pokemon. We have some fixtures that hold some of the Pokemon inside of it. Um, and now we have our project as well, where in settings.py we made quite a bit of configuration. For example, we have our allowed host for localhost and 0.0.0.0. This is in reference to the Docker network and how it works when we're connecting it to our local host. In installed apps, you can see here that we have the name of Pokemon app referencing to the app that we created. And then in our database configuration, we're specifying the engine that we're running, the name of the database we're connecting with, the name of the container that the database is running on, the user we've created, the password we created, and the port where we can find this database. If I take a look at my DB directory and open up that Docker file, you can see here that we're using Postgres 15. It's being exposed in 5432. The name of the database is PokédexDB. The user is student with the password of student. And if I take a look at my run DB, I am building my image and running my container, right, where the name of my container is DB container. All right. Finally, when I go to execute this project in Docker with Django, I'm building my image. I'm creating a volume to make sure that my memory gets updated or the that my container is actually able to see all the changes that I'm making in my VS Code locally. I am tying port 8000 of my local machine to port 8000 of my Django container. I'm naming it my Django container, and I'm linking the database container with the Django container. From there, I have access to my Django image, so I can easily reference it and be able to shut it down if needed. All right. Does anyone have any questions regarding the project structure before we begin our lesson?
I was just curious, why do you not want to close your containers?
Yeah, that's a great
Well,
question.
mhm.
Um, Sorry, did I cut you off?
No, I was just gonna say I didn't know if that made sense, but
Oh, yes, it does. So when it comes to our database container, because that's the one we want to keep here, right? So here's our lesson. We have our machine where our machine is currently hosting all of our Django application or all of our code. Currently, we have the Pokédex project, and we also have a DB directory, right? Now, from there, we're actually creating two separate containers that are tied to one another. We have our Django container, which this one actively copies and pastes. So there is a link between both of these that is happening, right? Those two are linked together. And wow, I can't spell Django. All right. Now, when it comes to my database, my DB container does not have a copy of anything, right? My DB container is quite literally standing a standalone database of PostgreSQL. Now, when I stand this database of PostgreSQL, the database gets connected through our configuration files over to the Pokédex DB, right? And then we make changes. Well, when we start making changes in PostgreSQL, we start storing data as SQL. But this data that we're storing inside of SQL only exists while this database is alive. If I shut down my Django container, meaning that I remove it from the picture, my data stays and it's still able to live, right? I can connect it to as many Django containers as I would like. And in all three of those different Django containers, they would all be connected to the same database with the same data being shared to one another. Oh, lost my arrow. There you go. So that all works great, right? And we're able to still see Pikachu existing inside of, or all the data inside of SQL existing in all of these different Django containers. Now the issue comes in where let's say that rather than deleting our Django container or stopping our Django container, which that is totally okay if we want to stop that one, let's say we stop our database container. Now, if we stop our database container and then bring it back, all of this data that we had before would be gone, and we would have an empty database, which means we would have to migrate all over again, and then utilize our fixtures to reconstruct our entire database. Right? There's a way to get back to a working state, but ideally, we could just keep our Postgres database running while the container can get shut down, or excuse me, the Django container can get shut down and then booted back up all over again. And this is very similar to what a deployment environment is going to look like. Your database is going to be living inside of a completely different place than your server. And your database may be communicating with multiple servers across the nation, right? Depending on how big your clientele is, where all of the servers would use one master database or at least a sub database that pulls from the master database every morning or something like that. Again, depending on what the user requirements are for your application. But then those servers standing in different locations would all communicate with one source of truth, making sure that all users, even though they're interacting with separate servers, they're receiving the same data. A good example I like to use for something like this is gaming examples. I really like to play Rocket League. Rocket League actually utilizes separate servers throughout the nation or throughout the world. Well, they all connect to one master database where all gaming data is shared for all the separate users. But in order to keep things efficient, we need a closer server so that we can get faster response times. Right. So separate servers are mounted across the nation or the world, and then all the users connect to those servers, but we all talk to the same database. Does that answer your question, Erica?
Yes, it does. And you said there's a way to rebuild it if you did close that container, though?
There is, yes. So in the case that that does happen, I'll go ahead and make us a checklist right here. So in the case that we shut down this container, we want to essentially rebuild the database. In order to rebuild the database, we would want to migrate all of our current migrations. And after migrating all of our current migrations, we want to install all of our functions, fixtures. I apologize. Uh, Install fixtures. And then after doing those two steps, your database would be back up and running, right? Where migrating would be something like Python, oh, hey, manage.py, migrate. And then installing our fixtures would actually be a little bit more complicated, where it would be something like Python, manage.py, load data, and then we would want to load data from the path. So in this case would be Pokemon app slash fixtures slash Pokemon data dot JSON. And then we would want to specify that we want to load it into the Pokemon app dot Pokemon model. There you go. And that would essentially get your database back up and running. And this is kind of like creating a backup. Currently, we're doing it manually inside of Python by creating fixtures. If you want to do a reference back to a deployment environment, we would actually have an S3 bucket where our database would dump all of our data into. It's going to be static so that in case we need to do some sort of rollback, we have an existing CSV file that could reload all of our data back into our database. And I'm not sure if it's CSV or a different type of file, but that's essentially how it works. That's my rabbit hole for the day. I'm sorry, everyone. Did that answer your question?
It did, thank you.
Of course. All right. Let's go ahead and move on into our lecture for today. So now, if in case you tuned me out, now it's the time to come back and let's go ahead and go into our lecture. Let's start talking about validators. Now, steps for creating a model. We want to create a model. We would then want to validate our fields. We want to make migrations and then test our model. All right. So let's break down each one of these steps. All right. When we go into creating a model, we've already seen this. But what exactly is it that we're doing when we're creating a model, right? What is this model representing? There's a couple of questions that we should be asking ourselves. So what is this model representing? How will it look inside of my database? What fields does this model need to work the way I intended to? And this last question here, it's going to become a lot more vital once we start getting into the last four lectures of our Django module. So it's going to become a lot more valuable to us next week. But make sure that you keep that question in the back of your mind as you're building databases, right? Essentially, you always want to keep your end state in mind, where your end state would be creating a JSON response, right? That's what we want inside of our API. All right. Now, as we're creating this model, we also need to be able to ensure that data is entering the database in a consistent format. That's where validators come into play. Can somebody read this slide, please?
Validators is a topic we haven't fully touched yet, but it is important we understand why and how to do this. Fields are great and most have some built-in data validations, but we need to have very specific controls over what kind of data goes into our database. Validators are a way to specify what format, length, max, and min value, and even data types is acceptable for each individual field.
All right. Fantastic. Thank you, Calvin. Perfect. So, essentially a validator is okay, so I want to build my chair, right? When I'm building my chair, I start thinking about the model. And when I think about a chair, I know that a chair should have a minimum of four legs, it should have a backrest, and it should have a place for bottom. All right. Now, that's at minimum. The validation process would be hey, what is this chair going to be made out of? Well, let's say that I want this chair to be made out of wood. So now I can ensure that every time a chair is being made, the material that I utilize to make this said chair is made out of wood. That's almost like when we define that, hey, I want this to be an integer field, or I want this to be a text field, right? We're specifying the type of material that we want to place here. Well, now we have to take into consideration measurements, right? The same measurement that I utilize for whatever is going to be that I'm actually sitting on in comparison to what's holding my legs up, they can't be the same sort of thickness. At the same time, if I'm trying to utilize something as a backrest, you can see that those legs for the backrest are a lot longer than they are for the very front, and that they can't be the same size or length. All right, each one of these have minute differences that we need to make sure that we take into consideration. Remember, when it comes to users will always find a way to interact with your program in an unintended manner or in a manner that you did not intend it to work. All right. You may try to make the form or you may try to make some sort of data input as straightforward as you can possibly make it. And there is a high probability that somebody will find a way to send you improper data. Now, when we get this improper data, we want to make sure that it doesn't make its way into the database, right? I don't want it just because it's a string or just because it's the right material that I'm looking for to be accepted. I want to be able to define, yes, this is the right material I'm looking for, but it's not the right size nor the right shape. That's where validators come into play. All right. Does anyone have any questions about validators? Perfect. Doesn't seem like we have any questions. Now, the make migrations and migrate process, this one is we've seen it yesterday, and it's pretty straightforward. When we make migrations, what we're doing is we're essentially building a file that will tell PsychoPG what it is that we're trying to communicate to the database. So make migrations scans all of the existing models and in our app. Once it scans all the existing models, it identifies if there's been any changes, which is actually really cool that it does that for us. If that wasn't a built-in capability, we ourselves would have to build these migration files manually, right? Which is just something else, another language and tools that we would have to add into our tool belt, and not necessarily something that we want. All right. And then we can migrate. That's where the actual model becomes reality. Now, you may think to yourself, well, when we're talking about validators, validators sounds very much like what concept in SQL? Do we remember utilizing the check in SQL? What was the check? What was this called? All right, the word that I was looking for here would be a constraint, right? A validator is very similar to a constraint. The difference between a validator and a constraint is that the validator is existing at the server level. So this exists within the server, meaning that before any sort of query is being created to attempt to enter a new and to insert a new entry into the database, the server runs the validation. If the validation fails, it never attempts to execute a query, right? It never attempts to run our insert query. All right. So I just want to make sure everybody's tracking. Validators don't exist within the database. They only exist in the concept of the server. All right. And then finally, test, right? Well, why write tests? If you don't write tests, you can't fail tests. Well, tests help us save money, help us save time by identifying errors for us. It ensures our product quality by having a set standard through test. And it facilitates refactoring because if I need to change something in my application code, I need to make sure that by changing a feature or by changing something, I'm not breaking everything else inside of my program. So tests are actually extremely useful. I'm sure that you guys have found them extremely useful when you're doing your test-driven development during your assessments. Um, and just in general, start getting used to writing tests, seeing tests. It is a very key part of software engineering nowadays. All right. So now testing a model. Once we've successfully migrated our model, we want to ensure all of its fields, validators, and methods are working correctly with proper input and breaking when receiving improper input. Now, we don't necessarily have to do this after migration. We could do this after make migrations. We just want to make sure that our model is working correctly before it actually gets inserted into our database. All right. Any questions regarding the process of creating a model? Perfect. Doesn't look like we have any questions. Let's go ahead and start talking back and taking a look at this validation process. So what we're going to do is we're going to go back to our Pokemon model and we're going to actually add some validation. We're going to ensure that this model is able to be validated and that it's receiving proper input. Let me go ahead and come back to my code here. When I want to add some validation, it's going to happen within the app. I'm going to try to close some of these unnecessary files so that we don't get too much noise here. And I'm going to come over to models. Now, in this model, I want to generate a couple of validations. There's some that you really won't need any sort of validation value. For example, this is caught attribute. It's a Boolean variable, right? It's always going to come in at true or false. So there's really no need for me to try to add some more validation than that. Right? If I were to try to add some more validation, like making sure that it's being placed in a specific format, then at that point I'm doing overkill and really just wasting my time. All right. But what I can do is for description. Well, description text field allows for an unlimited amount of text to be placed inside of my validation. Well, that's not necessarily something I want, right? Maybe for my description field, I want to set a min and max input size. It is not uncommon for you to go to something where you have to write like a story or something along those lines, and they tell you, hey, just so you're aware, there's a 500 character count limit. So if you exceed 500 characters, this is going to fail. All right, something to take into consideration there. All right, now we have the model of level, which we definitely want to have an upper and lower bound. Our name, which name as of right now accepts all kinds of different formats as long as it's interpreted as a string. Instead, I want this to hold a title format because it's holding a name. And I could say the same thing for Pokemon type. I would likely want it to hold a title format. All right. Is there any sort of other validation that we could add here? Okay, if there aren't any other validators that we can add here, then I have a question for you all. Why are we adding validators? What's the point of validators in this case?
To make sure we get the intended input.
Okay, nice. To make sure that we get the intended input. Fantastic. All right. So we want to make sure that we get the correct input in shape, size, format, and maintain data consistency. Thank you so much, Erica. So with that said, let's actually start implementing some of these validators. Now, we could write all of our validators from scratch. But writing all of our validators from scratch can be a little bit difficult. And it can turn into a pain if we're really writing every single validator from scratch. The whole point of Django, or at least I was told that the whole point of Django was that it comes with batteries included. So it would be a little absurd if you tell me something comes with batteries included and then tell me that I have to create everything from scratch when it comes to validation. Well, you would be correct. Django actually provides us built-in validators. And let me go ahead and share this. It is inside of our curriculum, but let me share it here inside of Corsair questions as well. Or excuse me, inside of the Corsair channel. Here I have all of the built-in validators that are provided by Django, or at least some documentation for me to take a look at it. We can see that there's a regex validator in case we want to utilize regex. We haven't dove into regex just yet, so we're not going to actually use that. There's an email validator, so in case we're utilizing an email field, an email validators come in. There's a URL field as well. Um, you can see there's a couple of validate fors, IPv address. There's an integer list validator, max value validator, min length. There's some decimal information. There's some pretty useful built-in validation that is happening here. Well, let's actually grab some of these and use them inside of our project. We can do this by stating from Django dot core, we want to import validators as V. And this is validators as V. Now, what this is going to do is it's going to give us access to all of the validators that are coming in within the validators module. And we can reference the validators module by the variable of V. We could name this whatever we want. We could say, hey, this is validators module, and that would work as well. But for simplicity's sake, we'll just call it V, or we could even call it val. All right. So here's my Pokemon type, which we want it to be in title format. That one's not going to come built in with Django. We're going to actually have to build this ourselves. So we'll save that for later. We can go into our integer field where we can say, hey, I want to add some validators. And validators takes in a list of validator properties. In this case, the validators that I would like to add, it says it needs a upper and lower limit. So immediately I think of validators dot min value validator. And I think of validators dot max value validators. So there's my upper and lower limit, where my lower limit would be the level of 1, and my upper limit would be the level of 101. Right? Something important to analyze here is that my min value validator is inclusive, meaning that 1 is acceptable, and my max value validator is exclusive, meaning that 101 raises an error. All right, so this is the equivalent of us saying that level must be greater than 0, but must be less than 101. All right. Does anyone have any questions over how we use this validator concept? Perfect. Doesn't seem like we have any questions. Let's go ahead and add this to description. So using this validators for our level as a guideline, how could we add some validators to our description? And let's hear it from somebody other than Erica or Calvin this time. All right, I'll go ahead and pass it on to somebody. Brandon, what would be the first step here for being able to utilize validators?
Just checking the string as it relates to like edge cases. So I guess like punctuation and numbers.
Okay, awesome. In this case, what we want to do is we want to set a min and maximum input size.
Oh, okay. I mean, would it just be similar, but instead of val, be char, like char?
Okay, so we said we want to do something similar, but instead of val, do char. So val is the module that we're importing,
Hmm.
right? So the val would have the state common. And you said it's something similar. So let's go ahead and do val dot. What would we utilize here?
No, I don't know.
Could we do, sorry to jump in, but could we do something like a length validator?
Nice. Yeah. What we're looking for here would be something like a max length validator, right? Where the maximum length, we could say that it's 500 characters. So let's do 501. And we could actually add a minimum length as well, where we can say min length validator. Let's just go ahead and say that the minimum is one character, right? Well, it's a description. Let's at least do something like 5 characters. All right. So there you go. There's our new validation for our Pokemon. Let's make sure these built-in methods work. I'm going to go ahead and make migrations here. Or actually, my server is running. So if my server is running, we should be good to go. Let me scroll to the bottom here, make sure that my server is up. All right, I'm going to come over to my site, refresh it. Everything here is working. And let's attempt to add a new Pokemon. In this case, this Pokemon, let's go ahead and name it Blastoise. Instead of 5, I want to do something like -13, right? This is still an integer. And for my description, I'm going to pass in, I don't know. Let's try to save this. Oh, now I get a couple of errors. I guess it says, please correct the error below. All right, so ensure this value is greater than or equal to 1. So this is making sure that I'm staying within my value validator or my min value validator. Let me make this 155. And for my description, ensure this value has at least 5 characters. I'm not going to add 500 characters in here, but I promise you that that is working correctly, right? If I go ahead and change this to I don't know, and then I attempt to save it, not only raises one error, where the error is stating, hey, ensure this value is less than or equal to 101. So I actually made a mistake here. Looks like this isn't exclusive. This is inclusive as well. So I want this to be 100, and I would want my length to also be 500. Where 101 would not raise an error. 100 is acceptable. All right. Awesome. So now we utilize some of the built-in validators. All right. In order to utilize built-in validators, we went to Django.core, imported the validators module. When we imported it, we created an alias for it, such as val. When we want to add validators into independent fields, we do it by adding the validators parameter. All right. Keep in mind that this here text field is just a class, right? That is looking for us to pass information into its initializer. Its initializer takes in default and it takes in validators, but it expects validators to be placed as a list of validators. All right. Does anyone have any questions regarding how to utilize validators inside of your models? Perfect. Doesn't seem like anybody has any questions. So let's go ahead and continue elaborating through this by building our own validator. Now, our own validators, we're going to actually have to create them in a separate file. So I'm going to change directory into my Pokédex project. In this Pokédex project, I'll go ahead and make a file named validators.py. And this is happening inside of the Pokemon app. Everything related to Pokemon will stay inside of the Pokemon app. So I've added this validators.py. And notice that this is completely empty. All right. Now the goal here would be to be able to hold a title format. So let's actually write some pseudocode here. Right, so I'm gonna def title format class. All right, so this function is meant to take in input of what kind of input would we receive?
Do like a string input.
Perfect. Yeah, we could do of string. Right, so that's very important for me. I need to make sure that I analyze that. So we're going to ensure that we receive the input of string. We don't have to worry about running any sort of string validation because it's going to assume it because we're only accepting the model as a character field. So anything that gets placed in here will always be accepted as a string. Okay, so we know we're going to accept a value, which will be of a string. And now, whenever this happens, I want to make sure that the value is in title format. Luckily, Python does have the title method. So ensure the input is in title format. All right. Now, if it's not, then I want to raise an exception. And in this case, it's not an exception. It's actually called a validation error. And let me make sure that that's what it's called because I don't want to misspell it. Yep, it is. So it actually raises a validation error where my validation error should make the user aware of their input errors and the desired input. All right. Now we've seen quite a bit of exceptions before, but this validation error should be completely new to us. And that is okay because our validation error is actually innate to Django. So we'll import from Django.pour.exceptions. We want to import a validation error. All right, this is batteries included. So Django is giving us the exception of validation error. Nice. Well, now let's actually work through this problem. All right, we receive an input of string. I don't have to worry about validating the fact that it's a string because I know that my model field is going to do it for me. Instead, what I can do is something as simple as if not, if the value is not equal to value dot title, then I want to raise my exception. And in this case, we want to raise a validation error. where the validation error takes in two things. One, the message, and two, we can describe the parameters that threw this error. So let's go ahead and go into it. For the message, I want, hey, this value must be in title format. I can specify where this error came from by adding the params and stating this is coming from, we can say its name, if it is name, and we could add name in there. And I don't think this is right? Because name would be assuming that we're always receiving it from the model of name. So we could do name and type, because that's the two places where we want to apply it. Then we can just state that the value that we input it. I guess instead of and, this would be or. Name or type. Otherwise, if it's successful, rather than returning a or raising an exception, I would just want to return the value. All right. And there's my validator, right? A validator. And let me go ahead and add this up top. A validator is a function that will ensure input matches restrictions and raise an exception, or let's call it raise a validation error if it does not. Right, I'm going to move this definition of title format up above the description string, because I would want this description string to stay within the function body. That way, if anybody wants to take a look at my code later on, they could read how this validator works. All right. Here's my title format. Does anyone have any questions up to this point? Perfect. Well, now that I've created this title format, I could actually use it within my test. Or excuse me, within my model. I can say from Django, or excuse me, not Django, from validators, I want to import my format name or title format. All right, ideally, I would probably name this title format validator and then add it here. So title format validator. And then I could add it into my validation string. You could say validators, where we're going to use the title format validator. And I can do the same thing down below. All right, where for validators, we're going to go ahead and use the title format validator. All right. Well, let's take a look at what our application looks like now. I'm going to go ahead and refresh it. Going to continue. Everything has been refreshed. Great. We see that Blastoise is failing. This value must be in title format. Let's make sure that is correct. It's not equal to value.title. Okay, great. So currently we have normal. Let's go ahead and do something like Rattata. Oh, no, we already have a Rattata. So let's go into Blastoise. Let's add the appropriate level now. Let's say, I believe we get Blastoise at around level 33. Nice. And And for description, let's say this is a giant turtle with water cannons coming out of its shell. All right. This is not a normal type. This is actually a water type. Let's see what happens when I place or attempt to save this. So that actually worked, which it should not have worked. And the reason why it didn't work is because I utilized this not value, right? I need to fix that. So let's go ahead and remove Blastoise. And yes, I'm sure. Let's try to recreate Blastoise by adding him. Okay, so again, the type, let's say this is water. We have Blastoise. We have an appropriate level. I'm not going to write this whole description again, so I'm just going to leave it as story unknown. If I attempt to save, I get an error. Hey, this value must be in title format. This value must be in title format. Great. I'm going to add this to say water, and for this to state Blastoise. And now I can go ahead and save it. And now Blastoise has been entered into my database successfully. All right. Does anyone have any questions regarding validators? How to leverage built-in validators, how to create your own validators, and how to implement them within the actual model.
When you're passing it into the model and the validator's parameter, well, why aren't you calling it as a function?
That's a great question. Yeah, so this is looking for functions to execute, right? The validator's argument or parameter that's being passed in here is looking for a list of functions to execute. Now, down below, this looks like we're sending in a list of calls, right? But in reality, all we're doing here is initializing a class. We're not calling the validator just yet. We're initializing the class. And when we're done initializing the class, this returns a callable function. Now, what happens is when I click save on this interface that we have here, so when I click this save, what it does is it attempts to read my table, right? When it gets to this validation process, it says, hey, now we're saving. So now it's time to actually execute and call this function. So once I click save, it will call the function with the value that I'm passing in, which in this case, it would be Blastoise or Blastoise. All right. I can't assume that that is what it's doing, and I can't call it just yet because if I call it now, it would be happening at the time that we create the model, not at the time that we're trying to create an entry into this row. Does that make sense, Erica?
Yes, thank you.
Of course. All right. Any other questions? All right. Doesn't seem like there are any other questions. There's one more thing we have to talk about, which is going to be tests. All right. So I've created my model. My model is working great, but now I want to make sure that my model continues to work great. You saw me just run into some issues right now when I was doing it myself manually. All right. Well, I don't want to be able to run into these issues again in the future. Instead, I want to make sure that this is sustained so I can utilize tests. You can see in the Pokemon app, there is a test file that I can utilize. Now, all of you should be familiar with this from yesterday. We did see some tests inside of our assignments, but let's actually go through the process of writing our test now. So here, I know that I'm actually going to be testing my model. So I can state that from models, I would like to import my Pokemon. And now I can write some validation test. So I can make my class of Pokemon tests, which should inherit from test case. Ideally, you wouldn't name it this way. It would actually be Pokemon tests. There you go. All right, so here are the tests that we're going to be doing within Pokemon. And then we can define our test. Now, a little bit of naming convention here. Whenever you're defining a test, it must be within a instance of a class of test case. So this is the class where we're inheriting from test case. And when you're defining a method test, because this is a method, you want to start off with test underscore. And then you could describe whatever it is that you're doing. But a Django test case will not identify the test unless it holds this test underscore at the beginning. All right. Let's go ahead and keep moving here. So we have this test underscore, let's call this 01, create a Pokemon. All right. This is going to take in self. And when we go into creating a Pokemon, we're basically going to do a try and accept block. For a try, I want to attempt to create a new Pokemon. So I could say something like, hey, I want to utilize Pikachu, where Pikachu is an instance of Pokemon, where Pokemon is looking for type. In this case, oh, I think it's Pokemon type. In this case, the type is of electric. It is going to be looking for a name, which in this case, it is Pikachu. It is going to be looking for a level, which we could not pass in a level since we have a default. And we could pass in a description, which I don't even know how I would go about describing Pikachu. Yellow, shocking, fuzzball. All right. And then we have our is caught, which we could leave as default for false. All right. Now, the purpose of this test is to make sure that this works correctly. All right. So what I can do here is if this is successful, well, I want all of my validators to be triggered. In order for my validators to be triggered and actually evaluate if this is proper input, I have to call a method named full clean. Now, what this full clean method does is it takes all of this data and runs it against all of the validation in our model to include validators. Without full clean, it wouldn't actually run the validator process. So this is vital, all right? This is very important. So executes validation functions. All right. If this is successful, then we want Pikachu to be saved. All right, so we can run Pikachu dot save, and then we can self dot assert. And in this case, we could assert is instance, where Pikachu is an instance of Pokemon. Now, in the case that there is an exception, I'm going to catch set exception. So I'm going to say from Django.core.exceptions. I want to import validation error. So I can accept validation error as VE. From there, I could print VE.message because there's something that went wrong and I need to know what went wrong. And then I could self.fail, right? Because this should not have failed. This should have been successful. Well, let's try this out. I expect this to work. All right, I'm going to go ahead and run Python manage py test. Okay, so it looks like we ran into some issues here. That's because I'm attempting to execute this information from within my local machine. My local machine is not aware of my database, and that's why it's telling me, hey, there's no such thing as database container. Okay, let me enter my Django container. So I'll say Docker exec dash IT. I want to enter my Django container in bash. If I run ls, you can see I have all of my information there. And I can run Python, manage py, test. And now my test is successful. All right. Here's my test case. I go and create an instance of Pikachu. I execute all of its validations to ensure that it works. And if it works, I can assert that Pikachu was placed incorrectly. Let's change this input. Well, now when I run this input, I get an error. And it looks like it's not giving me a message for this attribute. Did you mean messages? Sure, why not? That seems right. Okay, so we're running into some issues now. We can see there is a failure in the test. Here's my print statement. The print statement stating, hey, this value must be in title format. All right, so I'm getting back a messages list. If I wanted to take a look at the very index of a message, I could do index 0. And then we get some assertion errors. All right, so this self.fail is looking for a message. So we could actually just pass in the same exact attribute here. Give that message attribute. All right, let me make sure that I'm reading this properly. Oh, this value must be in title format. All right, perfect. So now I'm getting the assertion error actually showing up, telling me, hey, this value must be in title format. We're seeing it in multiple places, stating, hey, this is failing, and it's failing starting at the full clean method. All right, the full clean method raises an exception. We can see that print statement telling us that it's because this isn't in vital format, or excuse me, in title format. And we see it again during the assertion. All right. Well, now we can create a test that will handle improper input. So I'm just gonna go ahead and do C and paste it. Let's go ahead and turn this back to a passing test. All right. Now this one is supposed to fail. And this is going to be 02, create a Pokemon. Oh, this is too much indentation. Create a Pokemon instance, and we'll go ahead and add fail, where it takes in self. It goes through the same process. It's going to attempt to create Pikachu. We're going to pass in an improper electric type. We'll put our description as I don't know. We'll add our level as -10. And at this point, this should break every single validator that I've created. If full clean doesn't raise an exception, I want this to fail. These values shouldn't be acceptable. All right. Let's try. There you go. Okay. So it's going to attempt to create Pikachu. This should raise a validation error. When it raises the validation error, I can go ahead and do an assertion. For now, let's just go ahead and print, and let's just do self dot assert true. That true. Actually, we could just do this. Let's do that true is equal to true. I'm just gonna pass in true. There you go. All right. When we execute this test, we see that two tests have been passing. Now, when I try to take a look at the errors, we get this value must be a title format. That's coming from this print statement here. But currently we're looking at index 0. Let's remove index 0 and actually see all the different messages that are coming back. So now we're getting a series of messages. We get this value must be in title format. This value must also be in title format. Ensure this value is greater than or equal to 1. And ensure this value has at least 5 characters. All right, so we want to make sure that this fails. If we wanted to take this further, we could grab the exception message and we could say that ve.messages should be equal to the following. And in this case, rather than assert true, let's use assert equal. And assert equal takes in 1 and the second argument. Perfect. And now when we run the test, everything is working correctly. All right, now if somebody's trying to look at my test cases, they'll be able to see all of the errors that should have been risen by this input. They would see it both within the print statement and within the assertion message. I'm actually going to comment out the print statement because at this point they could just look at the assertion message. All right, so we can make sure that improper input will fail. That's what we're doing here on test 2. And we can make sure that proper input will pass. That's what we're doing here on test 1. And that's the Django test case suite. Again, when it comes to formatting, you must inherit from test case, and it must end with tests when you're naming your class. Whenever you go into creating your actual test methods, they must utilize test underscore. The numbering convention, that depends on where you're at, if they do numbers or not. It's an easy organization process. So you may not see this number. That's completely optional. The only required process is that test underscore is present. All right. At this point, does anyone have any questions regarding testing?
Can you explain what that self.fail is doing in the try block of the second test?
Absolutely. So what this self.test.fail is doing is it ensures that if a Pokemon is created, it fails the test. All right. This is essentially hard coding a failure. It's almost like returning false by default from a function. We're running through the test case. Full clean method should have risen an exception. Right?
Mm,
And if the full clean method doesn't rise an exception and it's able to save, then at this point, this improper input was successful in creating a database entry. And it shouldn't have been. So because it was successful, I want to make sure that my test fails. And that's what self.fail is doing. Does that answer your question?
yes, thank you.
Of course. All right. Any other questions? All right. Doesn't seem like there are any questions. Let me go ahead and stop the recording here.